Hi class, let's take a look at this question here. We have class intervals and frequencies and we want to find the mean. So in order for us to do this, we're going to have to pop into Excel real quick and do some calculations ahead of time, because StatCrunch is not going to be much use to us for this question, at least not on the surface. So the first thing we have to do is we have to find the midpoint of each of these class intervals. And in order to do that, we add the lower limit plus the upper limit and divide by 2. So the first midpoint is going to be 42, and then the next group is going to be 45 plus 49 divided by 2. That's going to be 47. And then the next one is going to be 50 plus 54 divided by 2, which is 52. And I think you can see the pattern here. Basically, it's incrementing by 5 each time. So the next one is going to be 57, and then finally the next one will be 62. So these are the midpoints here. Okay? So now put in the corresponding frequencies for each of these midpoints: 10, 6, and 2. And now to find the mean for this discrete distribution, I have to use expected value. And in order to do that, I have to take each midpoint times its corresponding frequency. I'm sorry, not frequency. We have to find the probabilities first, excuse me. So let's sum these up. And that gives me 26. Now find the corresponding probabilities. So this is going to be 1 divided by 26. Okay. This one will be 7 divided by 26. This one will be 10 divided by 26. This one will be 6 divided by 26. And then finally 2 divided by 26. Note that all of these probabilities sum to exactly 1. I need that in order to have a valid probability distribution. Now it's time to do the expected value. So take each midpoint and multiply it by its corresponding probability, and then add these together. Okay, or copy this down, I should say, and then finally add all of these products together, and that gives us a mean of 52.19, and I guess 52.2 is actually the answer that we need to 1 decimal place. Okay, which of the following best describes the relationship between the computed mean and the actual mean? Well, the computed mean, okay, is 52.2. The actual mean is 52.4. Clearly, these are actually very close together. Okay, and if I actually take the difference between the two, 52.4 minus 52.2, and then divide by 52.2, that is well within 5%. Okay, so the computed means are close to each other, okay, with the difference being between less than 5%, and I would expect this, okay, because of the central limit theorem. Thank you.